This video is a tutorial for the SpectraPave Pavement Optimization Module version 4.7, released February 2019. The Pavement Optimization Module allows users to incorporate Tensar Tri-X GeoGrid into their flexible pavement sections and compare with a conventional unstabilized pavement section. Incorporating Tri-X GeoGrid in the aggregate base layer below a flexible pavement results in extended pavement life, reduced initial construction cost and/or life cycle cost, reduced construction time, reduced fuel and water use, along with other considerations. The updated Pavement Optimization Module is intended to help engineers, public agencies, owners, and contractors better understand the true value of using Tri-X GeoGrid in their pavement sections. Please note that no previous knowledge or experience in pavement design is necessary to benefit from using this software. The Pavement Optimization Module is intended for the analysis of flexible pavements in accordance with 1993 AASHTO Guide for Design of Pavement Structures and is consistent with the AASHTO R5009 standard practice for geosynthetic reinforcement of aggregate base course flexible pavement structures. Proper incorporation of the benefits of Tri-X GeoGrid has been reviewed and validated by third-party experts. After installation, locate SpectraPave on your PC and open the file. If an update is required, there will be a red X next to the Updates button on the User Agreement pop-up window. Click the Updates button and the software will be automatically updated to the current version. Once the software has been updated, there will be a green check mark next to the Updates button. Click Continue to accept the user agreement and open the software. If at any point during the video you have questions or need additional information regarding functionality of the software, please click the live chat button in the toolbar to instantly connect with a Tensar representative during business hours. If the request for live chat is made after regular business hours, you'll have the opportunity to leave a message and a Tensar representative will respond at the start of the next business day. Additional training documents, such as the SpectraPave User Manual, can be found in the Reference Documents section of the Help menu. The default setting for SpectraPave is English Units. To select SI Units, click Unit Setting in the toolbar. This will need to be done prior to opening any of the application modules, as the units cannot be changed once an analysis has begun. To get started, click on Pavement Optimization to go to the Data Input screen. This screen contains all the required inputs to run the AASHTO 93 Flexible Pavement Design Equation. Additional information about each input can be found in the user manual or by clicking the blue underlined text. Enter the pavement layers in the top box for unstabilized pavement section, including asphalt, base, and subbase courses. Additional layers of asphalt can be added to account for intermediate binder and asphalt base courses, while the subbase course can be removed. If the total thickness of asphalt exceeds 6 inches, you'll need to click Thick AC in the toolbar. If the total thickness of asphalt is less than 3 inches, choose Thin AC in the toolbar. Once you've selected your pavement layers and thicknesses, edit the structural layer coefficients and drainage factors as needed. The layer coefficients reflect the structural contribution of each material to the total pavement section and varies by layer, material type, and location. Typical layer coefficient values may be found in the Department of Transportation or other governing agency pavement design guide for your area. Each layer thickness in inches is multiplied by its respective layer coefficient and drainage factor, then added together to determine structural number. Here I'm going to choose a pavement section of 2 inches of asphalt surface course, 3 inches of asphalt intermediate course, and 10 inches of aggregate base. Enter the pavement layers in the bottom box for the Tri-X GeoGrid stabilized pavement section. You'll also have the opportunity to make changes to the thickness on the results screen, so just take your best guess. You'll also need to select the specific Tri-X GeoGrid that will get incorporated into the pavement section. Each Tri-X GeoGrid provides a varying benefit to the section. Also note that aggregate base course name has been changed to mechanically stabilized base course to reflect the mechanical stabilization of the Tri-X geogrid. Here I'll choose 1.5 inches of asphalt surface course on 2.5 inches of asphalt intermediate course, 8 inches of aggregate base on the Tri-X TX8 geogrid. On the right side of the screen are the other inputs for the AASHTO 93 equation. The target traffic easels does not affect output. It's just a target value that will cause SpectraPave to notify you when your pavement section easels drop below the targeted value. Reliability and standard deviation are used to account for uncertainties in the pavement section. The initial and terminal serviceability reflect the condition of the pavement immediately after construction and at the end of its service life, respectively. Typical ranges of values for these inputs are provided by AASHTO or your local design guide. The subgrade resilient modulus is a measure of subgrade support to the pavement section. Various correlations from CBR and R value can be found by clicking on the blue text. Click on the Results tab to proceed to the next screen. At the top of the screen, you'll see a visual representation of the unstabilized and Tri-X stabilized pavement sections, along with the calculated easel value for each section. Easel stands for equivalent single axle load. An easel converts damage done to a pavement by wheel loads of various magnitudes from a mixed traffic pattern to damage done by an equivalent load. If the calculated easel value falls below the target traffic input from the previous screen, the calculated easel value will turn red. Further adjustments can be made to layer thicknesses on this screen using the arrow buttons, or you can return to the Data Input tab to make changes. The graphs further down the page represent the true value of incorporating Tri-X geogrid into a pavement section. To interact with this data, click the top right of each graph to expand the window and see additional information. Click the Edit Project Information button to change the inputs for these calculations. Initial construction cost compares the initial cost of constructing each pavement section. This is based on the project size and material costs in the first tab on the Edit Project Information pop-up. Note that the default cost of the Tri-X geogrid is 0, so this should be updated for more accurate comparison. You can connect to the live chat for assistance with pricing by using the Click Here to Get Geogrid Price button adjacent to the costs. By clicking on Labor and Equipment Cost Inputs tab, you can view the effect of variable labor and equipment on the initial construction cost. Note that this functionality is turned off by default, so estimated installed material costs should be entered in the previous tab. By unclicking the checkbox, these variable labor and equipment costs are now being calculated into the initial construction cost. Inputs for the next 4 value calculations can be found in the Material Transportation and Placement Rates tab. Dump truck trips reflects the reduced number of dump trucks required to construct the Tri-X stabilized section due to reduced asphalt base or excavated material volumes. These calculations are based on a 12 cubic yard dump truck. Reducing dump truck traffic reduces the damage done to adjacent roadways during construction, resulting in longer lasting roads. One dump truck does as much damage to a pavement as about 9,000 to 10,000 passenger cars. Construction time accounts for the reduced installation time associated with the Tri-X stabilized section due to reduced thicknesses of asphalt and aggregate. Fuel required calculates the fuel needs based on the construction time. The machine operation and installation rates and fuel consumption can all be found in the Project Info tab. Water required calculates the amount of water needed to properly install and compact aggregate base and subbase. The default water volume required is 25 gallons of water per 1 cubic yard of aggregate. This can be changed in the Material Transportation and Placement Rates tab. Life cycle cost is the total cost of owning a pavement over its design life. The life cycle cost is the initial construction cost plus the cost of all required future maintenance, discounted to today's dollars. Cost for future maintenance events can be found and edited in the Life Cycle Inputs tab. Last, the cost of traffic delay estimates the total cost of delays by the road users caused by construction. This is primarily relevant for work zones on public roadways. This tool estimates the average work zone delay per road user and the delay cost per day, which we can then calculate over the total construction duration. The inputs and source data for this calculation can be found in the Traffic Delay Inputs tab. Once your analysis is complete, you can save the file by using the Save button in the toolbar. You can also enter project information and print a report for your use. By clicking the Report button, you can choose which of the value calculation analyses to include in your report. Press Preview to view the selected reports. This concludes the SpectraPave Pavement Optimization Module tutorial. If you'd like additional training, have additional questions about the software or Tri-X products, or would like to discuss modeling a specific project in SpectraPave, please click the live chat button in the toolbar. Finally, we are always trying to improve SpectraPave, so if you have any feedback to provide, please click the feedback button in the toolbar. Positive or negative feedback is always appreciated. You can also reach us on our website, www.tensarcorp.com. Thank you.